Okay, in this video we're going to do a problem that has different questions that helps us go through different procedures of uh, finding the answers of these questions, and some of them have multiple way of finding the answer. So we're going to start with question A, which says find the y-intercept. Well, the y-intercept is, we'll do a small little graph here. This is the y-axis, and this is the x-axis. See, I have to be careful, I don't miss that. And let's find the y-intercept. The y-intercept obviously is the point where the curve of the function crosses the y-axis. Okay? That happens when x is equal to 0. So let me move this back to where it's supposed to be, here. And so we write y is equal to f of x, which is equal to 2x squared minus 12x plus 10. We're going to look for f of 0, which is, we replace the x by the 0 and find this cancels, that cancels. That means that the y crossing is 10. And that's the answer. So we'll draw that here. 2, 4, 6, 8, 10. That's 10 here. And that's 1 point. Now we're going to find the x-axis, the point where where y is 0. So y is 0 anywhere in this line here, which those points are actually the roots. There's different methods of finding the roots. In this case, we're going to use something I called, let me see, this is question B. Let me see if you can see that. Yes, question B. And we're going to use the factor form, which is also known equivalent to the intercept form. I don't know why some people call it factor form and intercept form. This is valid, and that is also valid. So you can call it whatever you want, but it's good to mention it so that you don't think that this is different procedure. It's the same procedure, because the factor form or intercept form is like this: x minus r, x minus s. Normally I use, well, it's okay. In this exercise, I'm going to use P and Q. P and Q. P and Q is, I find that is more commonly used, especially in places like here in Germany. You know, I see it all the time here in my kids' exams and books and things like that. So we're gonna use the factor form. So for that, we're going to write this. First, you know, when we look at the standard form of the trinomial polynomial, we can see that we can factor a 2 out of the function. 2, 12, and 10 are all divisible by 2. So we can take the 2 out. And then we have to find two numbers that multiply will give us the 5, and added or subtracted will give us -6. And those numbers are 1 and 5. But what do you call this? What sign should they be? That's the question. Well, in order to add the 6, this one has to be minus and this has to be minus. When we multiply them, they go to 5. So these are the two factors. So we'll write it here. Y is equal to 2 x minus 1 and x minus 5. Yeah? So that means that in order for this to be 0, because that's what we're looking for, in order for this to be 0, then this term has to be 0 or this term has to be 0, one of the two. For that, then we can determine that x1 is equal to 1, and on the other one we have x minus 5 equals 0, implies that x2 is equal to 5. So we can call this one equal to P, and this one we call it equal to Q. And this basically are the roots. So we can find it here on our graph, and they're both 5. They're both negative. And so 1, 2, 3, 4, 5. One is 1, and the other is 5. 2, 3, 4, 5. Okay, so we know that the parabola is going to go somewhere like this, and it's going to go somewhere like that. We have to find where the axis of symmetry is. But because you know that from here to the axis of symmetry and the axis of symmetry to the next root is the same distance, we can basically, by using our head, then it's better than using formulas, we can say that we can take 1, 2, 3, 4. Let me see, that doesn't make sense, does it? It's better to use, this is a 1 and this is 5. It's better to add them, 1 plus 5, and then we divide them by 2, which we get 6 divided by 2, and is equal to 3. So, but tree is just a number, you know. It doesn't talk about distance. Its tree is a number that is this number, this number here. So it's saying that the axis of symmetry is a point, it's a line that passes through the vertex. So we still don't know where the vertex. We know that the vertex is somewhere on tree. This is tree, this is 5, and this is 1. Yeah. We know that the axis of symmetry passes through the vertex, but we still don't know what the vertex is, do we? No, we don't know what the vertex is yet. So we're gonna find the vertex. Actually, the vertex is here. We already found it. We did find it. So, but do we know the y value of the vertex? No, we don't. This is minus, 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 minus. 1, 2, 3, 4, 5, 6, 7, and 8. And you'll be like, why you make a point in there? Well, we'll see. So, how are we going to find the y value of the vertex? Because the vertex is equal to h and k. But we know that h is 3, but we don't know what k is. But if we use 3 in our factor form, which is easier, we can also use this one too, the standard form. One or the other will give us the same. We can try both of them and see what happens. So we use the factor form first, and we say 2 divided by 3 minus 1, 3 minus 5. Yeah, this is equal to y. To the y, actually, you know, that's f of 3 will give us the y vertex. Yeah, y sub 0, y sub v, I mean, y sub v. And so this is equal to 2 times 2 times minus 2 equal to minus 8. With this line crosses, that's where the vertex is. So this is gonna go all the way up down there and then come back up here. We have a positive parabola because the leading coefficient, which is a, is positive. That means that this parabola opens up in this point here is called the vertex. This point is minus 8. Oops, let me see. Sorry, I didn't see that. It was being swallowed by the camera there. Minus 8. This is the vertex. The vertex point. Remember, anywhere you measure, this distance here is the same distance from here to there. And if you do the same thing here, it's the same. This distance here is the same as this distance, and so on. It doesn't matter where you do it. At the same point, the distance from the axis of symmetry to the function is the same distance. You can see that here is 2, and here is also 2, and so on. So you could do that the same thing all over the place. Okay, so we can use the standard form now. F of 3, using the standard form from up there, 2 of 3 squared minus 12 3 plus 10 will give us 9 times 2 is 18 minus 12 times 3 is 36 plus 10. We can take a 10 out of the 36, we get 26, and the difference between 18 and 26 and 36 is minus 8. Okay, so we now found the y coordinate using two different methods. Now we're going to use the vertex method, where it says y is equal to 8x minus h squared plus k. Okay, so how do we do that? Well, simple. Let me see. This point here of the vertex. Okay, so, well, let's write down what that point is. That point is x is equal to 3. So we can write f of 3 is equal to a, the leading coefficient, which is 2. This will be 3, and h is already 3. So this x comes from here, and this 3 comes from here. They're two different trees, And this is minus 8, because we already found it. This is equal to 0. That means, again, we get 8. Okay, so that's question B. Questions, let me see, that was question, no, this question was not B. This B finished here. This is question C, using the vertex. Yeah, this is factor. This is B. Let me see. This is question C. That I have to make sure that I mention that to find h, we take P plus Q and we divide it by 2, which is h is equal to, which I did here, P is 1 plus 5 divided by 2 is equal to 6 divided by 2, which is equal to 3. Yes, I needed to mention that. So now we can go to question D, which says, well, I think we answered that question already. Where's the axis of symmetry? Well, the axis of symmetry is h equal to 3. Okay, so the next question is E, the sum of the roots. Well, we Some of the roots, there's several ways of finding it. One obviously is simple. Sum of the roots is equal to p plus q, which is equal to 1 plus 5 is equal to 6. But it also, we can use the sum of the roots by being 2 times h. Two times h is the sum of the roots. So 2 times 3 is equal to 6. And yeah, yeah. There's another way of finding it, and this is come from the book. I haven't deciphered or derived this formula here. I don't know where this formula comes from, but it says that the sum of the roots is equal to minus b, which minus b is minus 12 divided by 2 is equal to positive 6. That's the last possibility. The formula, I don't know where it comes from. I have to derive that, but I'm not going to do it here. The last question is, what's the product? That's very simple already, because we know that the product, big P, is equal to P times Q, which is 5 times 1, which is equal to 5. That's the product. Yeah? And there's a formula that also comes from the book. It says that the product is equal to h squared plus q over a. I have not deciphered these two formulas here. They may come handy someday, somewhere, but I say that it's very unlikely that you're going to need this formula. So I would not recommend learning this formula or this formula, because we can find these points using, our finding the square, using the vertex form, factoring, we find all those solutions. So this, I would not use this at all. I don't know where this can come handy. I just don't know. So that's the last question. I mean, let me finish this by calculating it. So it'll be 3 squared plus minus 8 divided by 2. This is equal to 9 minus 4, which is equal to 5. Okay, that's it. That's the last question. Okay, in the next video, we're gonna work on complex roots. When does complex roots happens? If we have a y, well, let's say that we have the same formula here. Let me see, how do I make sure that I get a complex number? Where is my vertex formula? Here it is. In order to get, okay, I'm going to I'm gonna make this negative. Let's see what happens if I make that negative. So we'll have 2x squared minus 12x minus 10. Let's see what happens. So we'll take the 2 out. Minus 6 minus 5. I'm not sure that's gonna be a complex. Let's see what happens if I try to get the factors. It's not gonna happen. It's not gonna happen because you see that's the problem, because what two numbers multiply is going to give me, it's going to give me a minus. It just doesn't happen, you know. See, the only two numbers that we can use is 1 and 5, but there's no way that I can multiply this to get up negative 5. I have to make the 1 a negative or 5 a negative, but if I do that, then they will be subtracting, they will never get to 6. So that doesn't work. That means that I have to try to find the perfect square, and when I do that, I will have x squared minus 6x. Half of 6 is 3, and squared is 9, so it'll be 3 squared minus 5, yeah, because the 5 is still inside the parentheses. I did this too fast. I have to subtract the minus 3 squared, and then I will write the parentheses. Now we even. Now we good. And so now we're going to use the perfect square, which is this thing here, and simplify it. We have to use the negative sign and the 3, yeah, and then we have to take away, we have to take the 5 out of the parentheses and then the 3 squared out of the parentheses. Yes, remember, this is like this. The negative sign is outside the 3. The 3 is not negative, because if we put it inside, then it would look like a positive, and that is not right. So in order to take the 5 out of the parentheses, you have to multiply by 10. So we have minus 10, and this one is 9, but it's minus 9. And so we have to take it away from the parentheses. So we have to multiply by 2, so it becomes 18. And that whole thing is going to be equal to 0. And so look what happens now. This is exactly what I was trying to see. This is equal to minus 28. But look what happens when I try to clean it up. I mean, to clean it up means I'm trying to find the value of x. So I have to put, this is not good. I didn't see that. Well, anyway, I'll solve it anyway. But this is not what I was looking for. Let me write this 3 28 divided by 2, and then x is equal to, oh, wait a minute, where did I make it? Okay, then I have to put the square root here, plus or minus, and so this will be equal to 3 plus minus square root of 14. It's not what I was looking for. I should have checked my notebooks, but sorry about that. But complex roots look like the y will be equal to a real number and plus or minus a imaginary number, but multiply by I, and then we'll put imaginary number. I don't, I have to review this stuff. But that's what a complex number would look like. It has a real part and an imaginary part. Because basically what happens is like a complex thing, it's like it has to be viewed as having a real part, but then the x coordinate will be the real part, and this will be the imaginary. And so it will be like a vector. Well, kind of. I mean, they actually can be, you can think of it as having a, how to say, a direction, an absolute value of this distance of this thing in an angle. And this can get a little bit complicated, but we'll do that next time. I'm sorry about all this mess. Like I said, I thought that I could come up with a complex root, with my calculations, but I was wrong. So much for that. Thank you for watching. Don't forget to subscribe and leave a like or a dislike, whatever you like. And thank you for watching, and I'll see you next video.